Hello, welcome to a video on the model management extension from RapidMiner. We'll take a look at the model management extension, its operator compare models, and talk about what the operator is doing inside of RapidMiner and how to utilize that operator inside of RapidMiner. I have a test process here, so what I'll do is I'll add a few breakpoints in so we can look at what's going on and understand what's happening. But the general idea is I take a data set, so if I run this, for example here we have the test data set, the golf data in RapidMiner Studio, so we try to predict whether or not the day is playable depending on these four regular attributes. Now the next step is that we want to generate a bunch of models here with the idea that I'm going to utilize the compare models and model management extension to choose which one of these models is the best performing model, because I don't know which machine learning algorithm is best for my use case. So instead what I'll do is I'll generate a large quantity of models and have RapidMiner sift through which one is best for my data set. So this is a form of automation. Think of it on the same level as the optimize parameters operator in RapidMiner, where in that case I don't know what the best parameters are for my model. Here I don't know what the best model is for my data set, so instead I'll have RapidMiner select that for me. Now the next step here, all I do is use a multiply operator which sends my data set out to different ports, and I can hook up as many models as I need to from this multiply operator. Here I have a KNN, I've got a deep learning neural net from the H2O library, and I'm running a decision tree. So some fairly simple algorithms here with a pretty complex one in the middle. Now each one of these objects gets fed to a collect, which joins together these outputs to a single output port here. This just gives me a collection of objects. In this case our collection is all models. So now I have a collection of models, which if you notice this line is made up of 2 instead of 3, or instead of an individual line, to denote that I'm carrying multiple objects here. So if I continue on with this breakpoint, I can see now I have a KNN, one nearest neighbor model for classification. The model contains 14 examples with 4 dimensions of the following classes. If I open this up, I should get the output for a deep learning model, so I've generated a deep learning model here, and I also have a decision tree. If I come back into design, now the next step is, now that I have each one of these models, I need to know which ones are, or which machine learning algorithm is going to be the best for my use case. So now I need to come into the compare models. So first things first, I need to give it a folder with which to work in to store my results. So I've added in a project 1 folder there. Also this has a sub-process icon, which means that I can place operators inside of this. And also it's looking for a test input, so it's looking for testing data to test my model against. So that's what this testing requirement is, and here I've just retrieved the golf test set to do so. So now I'm going to come inside of the compare models. The compare models now looks to apply the models that we're feeding into it, and then it requires a performance operator output. So it requires us to have a performance operator in here, generate a performance vector, and send that out. Compare models will make its model selection based off of this performance operator. So the highest performing model will be the model that gets selected by the compare models operator. So now the last step is to finish running this process, which it'll kick off this apply model and this performance for each of our models, and ultimately show us the confusion matrix and the model for the selected object. Now that I've run this, I see that it shows the KNN over the other two, and if I come over to performance, I can get an accurate view of what's going on. Now, this data set's fairly small, so I have an accuracy of 71%, which isn't too bad. Better than a coin flip. But my data set's relatively small, so I'm not surprised that that is the case. But here, now that I've run each one of these models, I know which one is the best. So if I wanted to continue using this model, I could easily drop in a store operator. And if I were to store this, it would store just the KNN, because that's what's coming out of this compare models operator. That has been the model management extension.